We're going to start section 2 here of chapter 29, and this is going to be the pre-embryonic period, that period that we introduced in the last section. So remember, this one is going to be the one that starts with fertilization. So remember, the events leading up to fertilization is that the oocyte has to be ovulated. It's going to be released from the ovary, and it's going to start to travel down that fallopian tube. And at the same time, male sperm might be deposited into the vagina through sexual intercourse. So after that oocyte is ovulated, it's only viable, meaning it's only good, for about 24 hours following ovulation. So that's why there is a short period of time when people are trying to conceive that they actually need to, of course, have as much sex as possible if they are trying to conceive, because of the fact that that oocyte is only viable for 24 hours. However, the male sperm can stay in the reproductive tract for a few days. So what fertilization is, and we'll go through the whole process, is where those two gametes, that oocyte and the sperm, and you can see it right down here, they are going to fuse together, and they are going to take their 23 chromosomes, and they're going to put them together to where we are going to have a new diploid cell, and that is going to be, of course, your 46 chromosomes. It's going to combine the male and female genetic material. It's going to determine the sex at this point as well, that we talked about in the last chapter. So as soon as this whole process happens, as soon as fertilization occurs, it initiates a stage called cleavage that we'll take a look at later on. So fertilization is going to occur in the ampulla of the uterine tube. Remember, the ampulla is going to be kind of that middle section, but it's a little bit closer to the ovary. So let's take a look at the events. So this does give a synopsis of the events of fertilization, but we're going to take a look at them a little bit more. All right, so when when sperm are deposited into the vagina, they are actually not capable of fertilizing an oocyte at that point. So they are going to have something on the acrosome. So let me draw a beautiful little sperm here, because I can draw so well. Remember that here is the head of the sperm. And remember, in the head, you are going to have the nucleus, which is going to have the 23 chromosomes. But you are also going to have that little acrosomal cap on the top, or acrosome. And we'll take a look at these digestive enzymes here in a little bit and talk about how and what they're going to do. But we actually have a glycoprotein coat that is going to completely surround this acrosome. Does it look like this? I don't know. I'm just drawing something to kind of give you an idea. So I guess it's kind of like if an individual, it's really cold outside, they wear a little toboggan. The toboggan can be an acrosomal cap, but they're still a little cold and they need protection. So they have their hoodie, and the hoodie is going to be put over that cap. And that's the glycoprotein coat that you're going to have. It's there for protection. It's there to make sure that all of those enzymes, those digestive enzymes, are protected from the acidic environment in the female reproductive tract. Because remember, enzymes are very, very particular with pH. So if they are going to come into contact with that acidic environment, which they're surrounded by an alkaline semen anyway, or ejaculate, but still, eventually that's going to go away. And they need to protect those enzymes in there, because if they don't have the enzymes, they will not be able to break into that oocyte. So you have this little glycoprotein coat that is going to be there. What happens with capacitation is that glycoprotein coat is removed. It typically is going to occur in the fallopian tube. You have these little things called PEG cells, and PEG cells are going to go in and release something that's going to erase these little guys. So that's capacitation right here. There's another step in capacitation that we'll take a look at that is going to cause the sperm to get highly mobile or motile, whichever one you want to say, and that's another thing that happens there. So this can last several hours, and again, it happens in the female reproductive tract, specifically in the fallopian tube. So that has to happen. So let's take a look at these little sperm. So remember that a typical ejaculate is going to have millions of sperm in it. So if we look at it, it could have about 20 million sperm. However, these sperm not all of these sperm are going to make it to that little oocyte. You can see it down in the corner. Of those 200 million sperm that are deposited into the vagina during intercourse, only about 10,000 actually make it to that superior portion of the uterus where it starts to go into the fallopian tube. That's a lot, right? The reason why that they don't all make it is because remember we have that PSA that causes to liquefy the semen. Well, some of the sperm are going to leak out of the vagina just naturally. And they, some of them can't swim. A lot of sperm are actually going to be incapable of motility because some of them have two heads. Some of them have a big giant head. Some of them have two tails. So a lot of them are actually abnormal. Some of them will die in that acidic condition. So that's why not a lot reach there. And then even fewer are going to actually be able to go all the way into the fallopian tube, into that ampulla, and meet the oocyte. Maybe about 100 are able to do that. So can you think about that? You start out with 200 million and you only get about 100 that are going to make it to the oocyte. That's not a whole lot. And I know everybody's like, well, hey, you only need one, right? Actually, no. You need several sperm to help the one that is going to go in and fertilize it. So that's true up to a point. You only need one for fertilization, but you actually need several sperm, specifically their caps, in order to help that one sperm get into the oocyte. So it's kind of like, guys, the wingmen at the bar, right? Whenever you go to the bar and your buddies are there and they're your wingmen, they're trying to get you in good with this girl that you're interested in at the bar. That's exactly what's happening here with the sperm. So sperm act a lot like males. Not all males act like that, right? I apologize if you're like, hey, I don't do that. So another thing is you might be wondering, well, how does the sperm know exactly where to go? You know, they're not very smart. Some of them don't even know where they're going because they can't even move. So how do they know where they need to go? Well, the oocyte actually releases chemicals. So it displays this nice little positive chemotaxis. And they believe it's from the follicular fluid that's released at ovulation through that follicle. So it's going to have chemicals in it, and the sperm are going to be attracted to it. So another thing that happens is that you have these cumulus cells that are going to be surrounding the oocyte, and those are going to release progesterone. What progesterone does is it binds to these very specific channels on the flagellum. This causes a whole bunch of calcium to move in, and this is also going to be necessary for capacitation. Also, this thing called an acrosome reaction we'll talk about in fertilization. So it kind of hypermobilizes them to where they're going to kind of kick it up a notch. So as soon as those sperm get to the oocyte, they are going to immediately attempt fertilization when they reach it. So let's take a look at the phases of fertilization. So the first thing that they need to do is they have to get through these cells that are completely surrounding the oocyte, and they're there for protection, for protecting that, you know, in that environment. So there's two different layers that they have to get through. The first one is going to be the corona radiata, and you can see these little cells are going to be on the outside right here. So the sperm are going to start to kind of dig through, and they can just push through this layer. The problem is going to be when they get to this second phase, and they have to get through this zona pellucida right here. So this is where those digestive enzymes are going to come into play, and you can kind of see that greenish glow around this sperm right here. You can see that little greenish glow right in here. But remember, we actually have to have several sperm that are releasing its enzymes. I'm not sure why the book doesn't talk about this. But it's really important to know that you do need several of these sperm to go in and break through this zona pellucida. All right. So this acrosome reaction is going to be the thing responsible for releasing those digestive enzymes. So let's introduce those digestive enzymes from the acrosome. One of them is really easy to remember. It's called acrosine. The other one is quite a tongue twister. It is called hyaluronidase. Hyaluronidase. There's the ASE that is telling you it's an enzyme, and then the rest of it. It really doesn't tell you anything, right? But hyaluronidase is going to be one of those enzymes that helps go in and break through that zona pellucida. So as soon as you get enough enzymes, then you are going to have that one single sperm that is going to penetrate, make its way all the way through the zona pellucida. So as soon as that happens, and it really is only the nucleus that is going to go through. So if I drew what happens after this, here is the little nucleus, and then there's the flagellum right here. So as soon as this happens, this zona pellucida is going to harden again. And what this does is it makes sure that that one sperm is going to be able to fertilize it, and all the other sperm that are still trying to get in are not going to be able to get in. This is going to prevent something called polyspermy. So polyspermy is if you have two or more sperm that are entering in, where you have two sperm entering simultaneously. You can have three as well. And what this is going to prove to be immediately fatal, because what you have is you don't have 46 chromosomes that make a human individual. You have 23 triplets instead, or you have 23 quadruplets instead. That's not how twins are made, guys, or quadruplets. No. We'll talk about that later. This is going to be where you have too many chromosomes, and that is going to be fatal. All right, and then phase 3 of the fertilization process is where we are going to have fusion of the nuclei. So at this point, we actually really haven't had conception yet. We have just had the sperm that has put its nucleus into the oocyte. In order for fertilization and conception to actually occur, we have to join those 23 chromosomes together, because that, remember, that's what makes a human individual, is 46, the joining of those two. So so as you can see, they show how that sperm and the oocyte right here, the plasma membranes, you see how it fused, and then it dumps its nucleus, the pronucleus, pro meaning before. It's not, they don't consider it a true nucleus because it doesn't have the 46 chromosomes in it yet. But as you can see, only the nucleus goes in, and then it's going to come over here and it's going to fuse to the oocyte pronucleus, and that's where we are going to get our diploid nucleus, our 46 chromosome nucleus. Another thing that happens here is that secondary oocyte is going to complete its second meiotic division. Remember, it's been halted there in metaphase 2. So now what it's been waiting for is for the other ones to come in and line up, and it can finish the whole process here. And this is when it actually forms an ovum. So this is the point of conception. This is when you are going to have conception occur right here. So what it forms is something called a zygote. A zygote is going to be one single cell, one single diploid cell that's going to be formed. This is formed at the end of fertilization. It is going to occur in that ampulla as well, and it is produced because of the fusion.